نبينا محمد وعلى آله وصحبه أجمعين. We will talk today about some fundamental identities. Okay, identity is an equation which is always true. Okay, so all of these are equations that are always true for their domains, on the domains. First type of identities, the reciprocal identities. We know this from definition. We know that cosecant is the reciprocal of sine. So cosecant is 1 over sine, and secant is 1 over cosine, and cotan is 1 over tan. Of course, if cosecant is 1 over sine, then sine would be also 1 over cosecant. So if you know sine, you can find cosecant. If you know cosecant, you can find sine. They are reciprocal of each other. What happens if you multiply? If you multiply sine theta times cosecant theta, okay, cross product, if you multiply cross product sine theta times cosecant theta, what do you get? You should get 1. Sine times cosecant 1, cosine times secant 1, tan times cotan 1, because they are reciprocal of each other. Okay, the second type of identities, the quotient identities. Also, this from the definition, you can see this from the definition. Quotient means division. You have a fraction like this. Tan theta is sine theta over cosine theta. And cotan is the reciprocal of tan, so it's cosine over sine. Why tan is sine over cosine? You can see this from the definition. If we go back to the definition here, look to tan. What is tan? A over b. What is a over b actually? It is sine over cosine. If you divide sine by cosine, you will have a over c, this is sine, divided by b over c, this is cosine. Now, what to do if you have division between fraction? You change it to multiplication times the reciprocal. So now you multiply, you get, this is a over c, sorry. This is a over c. So c cancels with c, and the answer would be a over b, which is tan. So tan is in fact sine over cosine. Remember when we studied last time how to find sine, cosine, and tan of 30, 45, and 60? I told you tan is easy. Why? Because it is sine over cosine. So if you divide half by square root of 3 over 2, it would be half times 2 over square root of 3. 2 cancels with 2, and you get 1 over square root of 3. Remember that 1 over square root of 3, when you rationalize the denominator, you will get square root of 3 over 3, which is this one. And if you divide these two, you get 1. If you divide these two, you get square root of 3. So tan theta is sine theta over cosine theta. So don't ever worry about tan theta. If you know sine and cosine, just divide them and you will get tan theta. So these are reciprocal identities, and these are quotient identities. Let us solve some examples. Sine theta is 2 over 5. Cosine theta square root of 21 over 5. The question is, find the value of each of the 4 remaining trigonometric functions. We have sine and cosine. We still need to find the other 4 because we have 6 trigonometric functions. I will start here by finding cosecant theta, because cosecant theta is the reciprocal of sine. Sine is 2 over 5, so cosecant would be 5 over 2. Cosine is the reciprocal of secant, and secant is the reciprocal of cosine. So if cosine is square root of 21 over 5, secant would be 5 over square root of 21. And I need to rationalize the denominator, so I will multiply by square root of 21 over square root of 21, and the answer would be 5 times square root of 21 over 21. So I have cosecant and secant, still tan and cotan. So we used reciprocal identities to find cosecant and secant. Now I use quotient identities to find tan. I know that tan is sine over cosine. So it's 2 over 5 divided by square root of 21 over 5, which means 2 over 5 times 5 over square root of 21. You cancel 5 with 5 and you get 2 over square root of 21. You rationalize the denominator by multiplying by square root of 21 over square root of 21, and you get this answer. So what about cotan theta? You find cotan theta from here, okay? This is tan theta before rationalizing it. So cotan theta would be the reciprocal of tan theta, and it would be square root of 21 over 2. So these are the 4 remaining trigonometric functions. This is another question, exactly the same. Please do it by yourself. And this is another question, also exactly the same. You have sine and cosine. Find the value of the other 4 remaining trigonometric functions. And here is the answer for this exercise. Let us go to the book and answer some questions. Theta is an acute angle between 0 and 90. Sine theta and cosine theta are given. Use identities, reciprocal identities or quotient identities to find tan, cosecant, secant, and cotan, the other 4. Where necessary, rationalize denominators. So it is exactly what we did. We solved example. You can do number 17. Number 20. Let me do number 20 with you. So we did 2 questions about the same idea. This is sine, so I can find cosecant. Cosecant theta would be 7 over 6. This is cosine, so I can find secant. Secant theta is 7 over square root of 13. I need to rationalize the denominator, so the answer would be 7 square root of 13 over 13. Now I need to find tan theta. Tan theta is sine over cosine. So it's 6 over 7 divided by square root of 13 over 7. Then the division will be changed into multiplication by the reciprocal. So times 7 over square root of 13. 7 cancels with 7, and the answer would be 6 over square root of 13. So cotan theta would be square root of 13 over 6. But you need to rationalize the denominator for tan theta. So the answer would be 6 times the square root of 13 over 13. So we know now if we given 2 functions, sine and cosine, we can find the other 4. In fact, uh, it doesn't have to be sine and cosine. He can give me any 2 functions, tan, cotan, secant, cosecant, any 2 functions, and I can find the other 4. Okay, so for example here, let me solve this question. This is a question just came to my mind. Okay, assume that he gave me tan, I have tan, okay, and cosecant. Given tan and cosecant, find the other 4. Okay, I know cosecant, so sine would be 1 over 3. So I have sine. Cotan would be 4 over square root of 2. And I multiply by the conjugate. So I have sine and cotan. What I need to find here? Cosine. Okay, how to find cosine using quotient identities? Well, I know that tan is sine over cosine. If I need cosine, So I will change the place of tan and cosine. So I will have cosine theta equals sine theta over tan theta. Okay, just change the place of tan and cosine. You can do that because of the cross multiplication. So sine theta is 1 over 3. We said cosecant 3, so sine is 1 over 3, divided by tan theta, which is the square root of 2 over 4. So it would be 1 over 3 times 4 over square root of 2. So it would be 4 over 3 square root of 2. This would be cosine theta. If you multiply by square root of 2 over square root of 2 to rationalize the denominator, you will have 4 times square root of 2 over 3 times 2. But then you can cancel 4 with 2 to have 2 square root of 2 over 3. So this would be cosine theta. So if you go to the question and check, you will find that cosine theta is 2 square root of 2 over 3. And you can find the reciprocal. You can find secant theta, the reciprocal. So any two functions could be given, and you can find the other four using the reciprocal identities and the quotient identities. Let us talk about a new type of identities. We call them Pythagorean identities. Why we call them Pythagorean identities? Because they come from the Pythagorean theorem. We know in the Pythagorean theorem that in a right triangle, a square plus b square equals c square. Now, if you divide this equation by c square, you will have a square over c square plus b square over c square equals c square over c square, which is 1. Or you can write it like this. You can write it a over c all square, because if you distribute the power, you will have a square over c square. Now, what is a over c? Opposite over hypotenuse. Opposite over hypotenuse is sine. And b over c is cosine adjacent over hypotenuse. So this equation means that sine square plus cosine square is 1. So this is the first Pythagorean identity. Okay. Now, if you divide, instead of dividing by c square, if you divide by a square, you will get another identity. And if you divide by b square, you will get another identity. Okay. Or from here, from the first one, this is the most important one, sine square plus cosine square equals 1. If you divide this equation by sine square, okay, so sine square theta over sine square theta plus cosine square theta over sine square theta equals 1 over sine square theta. So I'm dividing everything by sine square. What is sine square over sine square? This is 1. What is cosine over sine? That's cotan squared. So 1 plus cotan squared theta equals, what is 1 over sine? Cosecant squared. So 1 plus cotan square equals cosecant square. That's this identity. Also, if you divide this identity, the main one, by cosine square instead of sine square, you will get 1 plus tan square equals secant square. So if you divide sine square theta this time by cosine square theta, cosine square theta over cosine square theta would be 1. And this would be 1 over cosine square theta. Sine over cosine is tan, so you will get tan square theta plus 1 equals 1 over cosine is secant, so you will have secant square theta. So there is a relation between tan and secant. And there is a relation between cotan and cosecant. Pythagorean identities. Remember, sine square plus cosine square equals 1. But sine plus cosine is not 1. Okay. Sine plus cosine is not 1. Sine square plus cosine square is 1. But sine plus cosine is not 1. Because when you take the square root, you do not distribute the square root. You can check this in any of these examples. For example, here in question 20, let us find sine theta plus cosine theta. Use your calculator or just add them. You will have 6 plus square root of 13 over 7. This is not 1. Okay, but if you find sine square theta plus cosine square theta, you will get 36 over 49 plus square root of 13 squared would be 13. 7 squared would be 49. Now 36 plus 13 is 49 over 49. This is 1. So please remember that sine square plus cosine square is 1. But if you take the square root, then square root of sine square theta plus cosine square theta is 1. Okay? Square root. But this is not equal to sine theta plus cosine theta. All right. An example, given that sine theta is 3 over 5. So we have sine theta, and theta is an acute angle. Find the value of cosine theta using a trigonometric identity. Okay, what is the identity that gives us a relation between sine and cosine? It is sine square theta plus cosine square theta equals 1. All right. What is sine square? 9 over 25 plus cosine square theta is 1. If you take 9 over 25 to the other side, we will have 1 minus 9 over 25. If you subtract, this is 25 over 25 minus 9 over 25, it would be 16 over 25. Now, cosine theta would be plus or minus square root of 16, which is 4, square root of 25, which is 5. So we have cosine theta could be positive or negative 4 over 5, but theta is acute angle. Okay, so because of that, cosine is positive. We cannot say it is negative. If theta is acute in a triangle, cosine the length of the adjacent over the hypotenuse, so it's positive. It cannot be negative. So you choose the positive value, and cosine theta is 4 over 5. Similar question, sine given, cosine theta is acute, find cosine. Please solve this one. Another one, solve also this one, and that's the answer. Okay, let us solve some questions from the book. Same questions. Theta is acute angle, sine theta is given. Use the Pythagorean identity to find cosine theta. So you can solve question 23. Similarly, please do it. Okay. Let us solve these exercises. Use an identity to find the value of each expression. Do not use a calculator. When he says to you, do not use a calculator, you need to show your steps. Sine 37 times cosecant 37. Without using a calculator, this is 1. Why? Because since cosecant 37 equals 1 over sine 37. And if you multiply sine 37 times 1 over sine 37, sine 37 will be cancelled with sine 37, and the answer is 1. Okay. Sine square theta plus cosine square theta, this is just 1. Why? Because sine square theta plus cosine square theta is 1. So sine square any angle plus cosine square the same angle will be 1. What about secant square minus tan square? Is there a relation that relates, identity that relates secant square and tan square? Let us go back to the Pythagorean identities. This identity says that 1 plus tan square equals secant square. All right. So 1 plus tan square theta equals secant square theta. Okay. Here he did what? He took tan to this side. Okay, so if you bring tan to this side, you will have 1 equals secant square theta minus tan square theta. So always secant square minus tan square would be 1. So here I have secant square 23 minus tan square 23. The answer is 1 without using a calculator. If you want to check using the calculator, you will find that the answer is 1 using the identities. The second objective is about cofunction of complements. Okay, let us first define what we mean by complements. Two positive angles, they have to be positive, are complements if their sum is 90 or pi over 2. So for example, 70 degrees and 20 degrees are complements because their sum is 90. 60 and 30, 45 and 45, 80 and 10. All of these are complement angles. Okay, now if we consider this triangle, we know that this angle, if this angle is theta, the acute angle, and this is a right triangle, this is 90. So if this is theta, the sum of these two angles should be also 90, because in a right triangle, this is 90 and the sum of these two is 90. So this angle would be 90 minus theta, or pi over 2 minus theta, if we deal in radian. Okay, let us now find the 6 trigonometric functions of this angle, 90 minus theta. If I ask you to find sine 90 minus theta, what is the definition of sine? The opposite over the hypotenuse. What is the opposite? It is b. What is the hypotenuse? It is c. Okay, now this is the sine of this angle. What about theta? What about the angle theta? B over c is what for the angle theta? B over c is cosine theta, because b is the adjacent and c is the hypotenuse. So b over c is cosine theta. Oh, so cosine theta is sine 90 minus theta. So there is a relation between these two angles, and these two angles, by the way, are complements because their sum is 90. So sine theta is always cosine 90 minus theta, and cosine theta is sine 90 minus theta. Also tan theta is cotan 90 minus theta, and cotan theta is tan 90 minus theta, and secant theta is secant 90 minus theta, and cosecant theta is secant 90 minus theta. So there is a relation between secant and cosecant, tan and cotan, sine and cosine. You can, if you deal in radians, you can replace 90 by pi over 2. Let us solve this example. The question, find a cofunction. These are called cofunction identities. Why co? Co from complement, okay? Cofunction identities. Find a cofunction. Cofunction to sine. What is the cofunction of sine? Cosine. What is the cofunction of tan? Cotan. What is the cofunction of secant? Cosecant. So find the cofunction with the same value. The cofunction of sine would be cosine. Sine 72 would be cosine what? 90 minus 72. Okay, that's the definition. Sine theta is cosine 90 minus theta. So it would be cosine 18 degrees. If you check by the calculator, use the calculator, sine 72, cosine 18, you will find the same answer, exactly the same. So this is very nice. You can change from sine to cosine. Okay. What about cosecant? What is the cofunction of cosecant? The cofunction of cosecant is secant. So cosecant an angle is secant 90 minus the angle, or because pi over 3 in radian, so pi over 2 minus pi over 3. If you use the calculator to subtract pi over 2 minus pi over 3, you will find pi over 6, because it would be 3 pi minus 2 pi over 6, so it would be pi over 6. This is how you subtract pi over 2 minus pi over 3 using the formula a over b minus c over d would be b d a d minus b c. Same question, find the cofunction with the same value as sine. Okay, 46. We solved an example for sine, so you can do it. This one, 72 here, 46, please do it. And here, sine 7, and this is the answer, it is cosine 83. What about cotan pi over 12? What is the cofunction of cotan? Well, the cofunction of cotan is 10. So cotan pi over 12 would be 10 pi over 2 minus pi over 12. And you can use the calculator and find the answer. The answer would be 12 pi minus 2 pi over 24. So it would be 10 pi over 24 or 5 pi over 12. I did this quickly. In fact, it is better to change 2 to 12. So multiply 6 pi over 12 minus pi over 12, and you can see that the answer is also 5 pi over 12. So cotan pi over 12 equals 10 5 pi over 12. Also, 10 pi over 9 would be cotan 7 pi over 18. Some exercise from the book, find cofunction with the same value, sine, cosecant, tan. Please do all of them similarly. I stop here and I open the floor for your questions.